F equals kx. Force equals 4.5 newtons. Extension equals 15 millimeters, which we immediately convert to 0.015 meters. Therefore, the spring constant K equals 300 newtons per meter.
Now that calculation, right there, it isn't just correct. It is a flawless, top-band answer. Writing it out exactly like that guarantees you full marks on a Cambridge IGCSE Physics 0625 paper. And in this explainer, we're doing something completely different. We aren't just going to casually study the physics today. No, we are going to reverse engineer exactly how to build that bulletproof answer from the ground up, starting right inside the examiner's mind.
Okay, so think about chapters 4 and 5 in your Cambridge Physics coursebook, turning effects, so moments in center of gravity, and forces and matter, which covers stretching springs and Hooke's law. These two specific areas are notorious across past papers. They are massive, heavy mark losers. This is where the majority of students just bleed critical grade boundary shifting marks. And it's not because they don't understand the physics, it's because they simply don't know how to play the exam game.
Section 1, the painful learner mistake, and exactly why ordinary revision totally fails.
Let's look at what happens when a student relies completely on textbook memorization and totally ignores mark scheme thinking. They walk into the exam, they see a simple Hooke's law calculation, and they confidently step right into a carefully laid trap. Here is that painful learner mistake in action. A student writes out K equals 4.5 divided by 15, which gives them an answer of 0.3. They feel great about it, but they just scored a flat 0. Why? Well, because they completely missed the basic standard unit conversion from millimeters to meters. Now compare that to an examiner-approved calculation. Force is 4.5 newtons, extension is explicitly converted to 0.015 meters, yielding 300 newtons per meter. The big takeaway here is that ordinary revision teaches you the formula, sure, but mark scheme thinking, that teaches you to hunt for the unit mismatch before you ever even touch your calculator.
And honestly, that unit mismatch is just the tip of the iceberg. Examiners see the exact same high-stakes mistakes repeated year after year in Cambridge papers. We are talking about missing units on final answers, rounding numbers way too early in multi-step calculations, totally flipping the variables on graph axis labels, offering incredibly weak practical improvements, like, just saying use better equipment instead of use a fiducial marker to reduce parallax error, or using the wrong variables entirely and writing explanations that are just so vague they don't actually answer the prompt.
Which naturally leads us to ask the single most important question you can possibly ask when sitting down for paper 3 or paper 4. What is the examiner actually looking for? When they're sitting there with their red pen scanning your handwriting, what specific triggers literally force them to award you the marks?
Well, in a moment, I'll show you the specific examiner clue that changes this answer completely. But first, you need the framework that makes that clue obvious.
Section 2. The Mark Magnet Framework.
Let me introduce you to the Mark Magnet Framework. This is a bulletproof exam strategy explicitly designed to pull marks directly from the Cambridge mark scheme onto your paper. It literally forces you to stop writing like a student who's just trying to remember a textbook and start writing like an expert who's actively checking boxes on an examiner's grading sheet. It has 4 mandatory steps. Step 1 is concept. You have to clearly state the key definition, law, or equation, like F equals kx. Step 2 is evidence or data. Pull the specific numbers or observations given in the question. Step 3 is scientific reasoning, logically linking that evidence back to the concept. And step 4, which is an absolute game changer, is examiner wording, using the precise, specific vocabulary printed in the official marking guide.
And applying this framework to our heavy mark losers like Hooke's law and moments demands some really explicit actions. You cannot just write down a naked final answer even if it's correct. No way. You must provide the explicit equation. You must show the substituted values, and you absolutely must include the correct units before any final answer is written. That substitution step is your ultimate safety net. Even if you somehow punch the wrong numbers into your calculator under pressure, showing the examiner your substitution with the units will often secure you those crucial method marks.
Section 3. The Spot the Error Challenge. Okay, let's escalate the stakes a bit. It's time to put this framework to the test with an interactive Cambridge-style application question based on turning effects and stability. I want you to actively think about this as we go. Imagine a classic student response explaining why a racing car is designed the way it is. The student writes, "The center of gravity is low, so it is stable." Now pause and predict for a second. Look closely at this notoriously vague explanation. What method marks are missing here? Why will this answer score a maximum of just 1 mark when the question is actually worth 3? Did you spot it? The answer fails because it completely ignores the scientific reasoning required by our framework. It states a fact, right? The center of gravity is low, but it completely misses two vital elements. First, there is absolutely no mention of the base width of the object, and critically, there is no mention of the line of action of the weight relative to the pivot. The student just hasn't linked the center of gravity to the actual physical mechanics of tipping over.
Section 4. Examiner feedback and correction.
So, let's step into the role of a strict Cambridge examiner. If I am marking this, I'm shaking my head. The concept of stability in physics 0625 is a two-part relationship. You can't just talk about the height of the mass, you have to talk about the area it rests upon. We need to correct this flawed reasoning using our exact mark magnet framework to guarantee we get every single available mark. Here is your ultimate corrected response: to increase stability, lower the center of gravity, and widen the base so the line of action of the weight remains inside the base area. This is incredibly safe examiner-approved wording. Notice how we hit the concept, which is stability, the evidence, low center of gravity and wide base, and the scientific reasoning, using the exact examiner wording, the line of action of the weight remains inside the base area. If that line of action falls outside the base, the moment of the force causes the object to topple. That right there is the exact phrase examiners are hunting for.
Now, applying this framework isn't just for theory and calculations. If you're tackling Paper 6 or the practical investigation questions in Paper 5, this framework translates directly into stringent practical checks. When you're designing an experiment for stretching springs, you must explicitly verify your apparatus. You have to state your safety precautions, like wearing goggles in case the spring snaps. You must ensure your table design has headers with units, your graph scales take up more than half the page, and you actively identify anomalous data. Every single one of these checks is a mark magnet.
But here is where things get truly complicated. It's one thing to calculate a spring constant or explain stability when all the information is nicely, neatly presented to you. But what happens when the exam throws a total curveball? What happens when you are handed a flawed practical experiment, complete with messy data, terrible variables, and completely unstated uncertainties, and you are asked to evaluate it?
Without a bulletproof system for evaluating data, those high-level analysis questions will completely drain your time and your marks. Learning the top-band evaluation framework is an absolutely mandatory step to surviving the hardest data analysis questions that Cambridge can throw at you. You simply cannot master Paper 6 without it.
Which is exactly why you need to move on to our next explainer on top-band evaluation frameworks right now. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click the next explainer on screen now to unlock more mark magnets. Because ultimately, you have to ask yourself, will you walk into your next exam hoping to remember the textbook? Or will you walk in ready to completely command the mark scheme?